Okay, section 67. Contents, examples, exercises. My name is Ron Bannon. This is a draft version of my adaptation of Webster Wells's Advanced Course in Algebra dating back to 1904. The PDF document is being made available to the participants of the PRISM Mathematics Project. I realize other people may be watching these videos, and if you are interested in getting a copy of this, it will be published at a later date. Right now it's not published. All right. If you need to reach out to me for whatever reason, including you want to know when it's going to be published, my email address is Bannon, that's B as in boy, the @ symbol, NNON.US. All right, let's take a look. Let's look at the contents. This is stuff you have to read through. It's not easy. All right, these are special methods for the solution of simultaneous equation higher degrees. All right, they're not easy. All right, I want to point out it's not going to be easy. They do all kinds of tricks over here, and you may wonder where they get these tricks from. They're writing problems that represent tricks. There's no doubt about it. All right. Now I got to be honest with you though. It can't hurt to learn some tricks. The more things you witness people doing with mathematics, the better. All right. Now, one thing I want to point out this problem over here, and certainly I'll look at the key, but I want to point out, looking at this thing over here, I'm noticing that there's some terms over here that might be related to a binomial expansion. So I'm going to write that down for you. The binomial expansion for x minus y cubed, and this should be something you'll be able to do. This would be x cubed minus 3x squared y plus 3x y squared, and then you would get minus y cubed. So I'm going to point out I'm sort of seeing this. So what do you mean by I'm sort of seeing? I'm seeing this. I'm seeing this. And I'm seeing something like this over here. I'm sort of seeing that. So what I want to do is I'm going to take the second equation and multiply it by minus 3. Let's put that down for you. You're going to get x cubed minus y cubed. And by the way, this may lead nowhere too. I'm not saying it will lead somewhere. Equals 19. And let's see what you get over here. You would get minus 3x squared, y. Then you get plus 3xy squared is equal to minus 18. Well, what do I notice about this immediately? If I add these two equations together, no elimination will take place, but I get something that I really want to recognize. I'm just copying it down, by the way. And what does this tell me? This tells me this. It tells me x minus y cubed is equal to 1. Well, that looks pretty simple. So what does it tell me? X minus y would have to be equal to 1. Let's keep going. Now, if you get this over here, I want to point out, I'm kind of looking at it and see if I can figure something out over here. And let's see what we can do over here. We got something pretty simple relationship over there. You know what I'm going to do? I'm going to take this equation now. There's a lot of tricks. There's no doubt about it. And I'm going to see if I can divide through by x minus y. We're using something we did in the past. That's x squared, y. Well, you know what I'm going to do? Instead of doing it, I'll just factor it and see what happens. Maybe it's going to be pretty simple. I don't want to divide. Division's too much work for me. Let me factor it. So I'm going to say xy comes out, right? And we're left over there. What do you get? X minus y is equal to 6. Well, x minus y is 1, so I get another relationship. What's the relationship going to be? Xy is equal to 6. So now I got two simple relationships. I'm going to outline those again for you. I got this guy here and this guy over here. I want to keep moving along and see if I can do it. And I'm going to do elimination now, but I'm looking at these two guys over here. Two simpler relationships than the above relationship. All right, let's take a look. What do you get? X minus y. Well, what's y? Well, if I did this equation here, y would equal 6 over x. I'm going to multiply both sides by x. You get x squared minus 6 equals x. I'm going to try to get 0 out of it. X squared minus x minus 6 equals 0. X and x. Let's see, 3 and 2, right? Minus plus. So x would equal minus 2, or x would equal 3. All right, so I got to do something over here. And by the way, when I do that, I'm looking at this equation because it's easier for me. What's y going to be equal to? And we'll check it, by the way. What's y going to be equal to? Let's take a look. That would be minus 3, right? And what would y over here be? 2. And let's see if that's true. Yep, looks pretty good. All right, so I got two solutions over here. The solution I got is minus 2, minus 3. And the other solution I get is going to be 3, 2. What I want to do is I want to discuss if they, in fact, are solutions of the original system. Because they did a lot of manipulation, right? And I'm going to see if it's true. All right, let's check this one first. What do you get over there? Well, if you cube the x, you would get minus 8. If you cube the minus 3, you get minus 27. So I'd say plus 27. Well, that certainly does equal 19. Let's see in the second equation what you get. X squared would be 4, and the y would be minus 3. Minus x, well, x is minus 2, right? Times y squared, that would be 9. And they said it's equal to 6. I don't know. What do you get over here? You get minus 12 plus 18, which of course is 6. This worked out beautifully, all right? So I know this is a good answer. Let's try this one over here. What do you get? 27, right? That's cubed, right? Minus 8, that's certainly 19. Let's do the second equation, even easier. You get 9 times 2, which is 18, minus 3 times 4, which is 12. That equals 6. This is a good equation. All right, so what I'm going to do over here is I want to point out, I do graph them for you. How do I graph them? I'm using a machine to do it. This figure over here. And I just want to outline the points of intersection right here and right there. And are they the points I want? Yep, 3, 2. I do see it. The other point I'm seeing is minus 2, minus 3. Looks pretty good. We did a good job in that one. All right. Granted, you may be looking at these curves and say they'd be terribly difficult to do by hand. I agree with you. They'd be pretty tough to do by hand. Are they doable? Yeah, maybe. The bottom line is other ways of doing the problem, but the bottom line, the way you stumble on it, the way you try it, is good. Now, I got to be honest with you. These are rather tricky. And someone says, why are they tricky? Well, they're really not tricky if you understand what the trick is. All right. Well, if you understand the trick over here. And so I'm just going to walk you through the trick. All right. Now, by the way, this would take me a long time to stumble on if I were just simply working on it and didn't know the trick. But here's the deal. The more tricks you see, the more likely you'll know that there's a trick to doing certain problems. Now, in the real world, a lot of things are tricky too, and it's nice if you have options about how to solve certain problems over here. So one of the tricks they're doing over here, and I'll write this down for you. Let me get my pen out again. They say let x equal u plus v. This was known as a substitution. And then they said let y equal u minus v. I want to point out why they're doing that. If they add it together, right, what would they add? X plus y would equal 2u. Now someone says, do I see that in the problem? I do. And really what they're doing, they're introducing some variables here that allow me to make a simpler statement. Now I'm not saying the other one's going to be simpler, but I'm saying this equation here can now be written as 2u equals 6. You get the idea what I'm doing? And what would u equal? U would equal 3. I hope I didn't go too fast with that. So again, we saw a substitution that might work. I'm not saying it's going to work for us, but I saw something that may work for us. All right, x plus y is 2u. If 2u is equal to 6, u is equal to 3. So now what I'm going to do is get my eraser out. I'm going to erase this business over here. It's pretty simple to do, right? And I'm going to say my substitutions now. I'll write them down for you. The u is 3, right? Oops, I'm sorry about that. And again, I'm not saying it's going to work in the second equation. So 3 and 3. I'm going to erase this business over here. I'm kind of done with that. It's a nice trick, by the way, if it works. If it doesn't work, you know what? It wasn't too bad to come up with it. So what I'm going to do over here, I'm going to plug it in. I'll get an equation of one unknown. And the way I'm going to do over here, I'll write this down for you. X cubed plus y cubed, I'm looking at that, is x plus y. X squared minus xy plus y squared is equal to 9xy. Well, what do I know about this over here? I know x plus y is 6. So I'm going to write that down for you. 6x squared minus xy plus y squared is equal to 9xy. All right, I'm going to multiply this out. You get 6x squared minus 6xy plus 6y squared is 9xy. What do you get? 6x squared minus 15xy plus 6y squared equals 0. All right, I got to do something now. What am I going to do? I'm going to do this. And let's see what we end up with. 6x squared. Well, x squared is going to be 9 plus 6v plus v squared. And it's a lot of work. I'm not saying it's not. All right, we're doing this over here. Minus, I'll write this right below it, x times y. Well, that's going to be 9 minus v squared. Again, we're looking at this. Plus 6y squared. That's going to be 9 minus 6v plus v squared. That equals 0. Now, granted, some say you're running out of room, maybe, but I think I can do this. And I'll write it down for you. That's going to be 6 times 9, 54. I'll try to be careful. 36v plus 6v squared. That's done. And then I'm going to get minus, well, let's see, that's going to be 90 and 45, 135, plus 15v squared, plus 54. I'm running out of room, so I'll put it over here. Minus 36v, and then plus 6v squared, right? And that, of course, is equal to 0. Let's look at a tough one, doesn't it? So let's take a look. And I get 108. This is done. This is none. You get 12, and 15 is 27v squared. Minus 135 equals 0. I'm going to put it in order, though. This is an equation of one unknown, much easier for me to handle. I'm sorry, I made a mistake over here. And where's my mistake? Oh, no mistake. Let me make sure I did that right. It's 135. That's going to be minus, what is that going to be? Oh, 27. Yeah, 27. And what do you get over here? 27 v squared minus 1 equals 0. And you get v equals plus or minus 1 now. I didn't want v, though, did I? Let's go back over here. And let's see if we can do it. So let's say v is equal to 1. X would be 4. Y would be 2. Let's say v is minus 1. What would you get? Well, let's write this down. X would be 2, and y would be 4. So I'm going to say that these are my answers. Let me just point out what I mean by that. If they're answers, they're going to solve the system. Let me get my eraser out. I'm going to check, and I'll check one at a time. And I'm going to check this one first, because it looks easy for me to do. And what do you get? 4 cubed is 64. 2 cubed is 8. And that's 9 times, what's x times y? 8. 64 plus 8 is 72, and 9 times 8 is 72. Well, it certainly worked in this first equation. Would that be agreed? Okay, let's see if it works in the second equation. Well, what's 4 plus 2? It's 6. It worked there too. This is a good answer. Let's see if this is a good answer. Now, by the way, I hope you realize that this is symmetric. Let's say you don't realize it's symmetric. Do the work. What do you get? 8 plus 64 is 9 times 8. That works. And 2 plus 4, of course, is 6. I found two solutions. All right, now so that's really tricky what you did. No doubt about it. All right, it's tricky. Now the answers are listed for you, and there's a graph over here. What's the graph? I hope you realize they give you the points of intersection, 4, 2, and 2, 4. We got that. All right, these are tough questions, by the way, and I'm not saying they're not tough questions. That was number 2, right? Let's go to number 3. And kind of looking at this guy over here, and someone says, what are you going to do with this guy over here? And, you know, I'm saying it really does look tough to me. I don't really see much about it, but I guess you could try to maybe factor or something, but it doesn't look like it's going to go anywhere. So we're going to make another stab at it. And you know what? I don't know. Maybe this will work again. So x equals u plus v, and y is equal to u minus v. We just tried that before, right? You know, if you add that together, x plus y is 2u. I don't see any x plus y in the problem, but maybe a little bit, right? A little bit. And I don't know, let's just put this down. So what's x squared? It's going to be u plus v squared. What's y squared? It's u minus v squared. What's 2x's? We'll write this down. 2u plus v, right? Let's keep going. Plus 2u minus v equals 23. I'll simplify that later. But I want to do the bottom equation too, because who knows, maybe something nice is going to happen. What do you get? U plus v, u minus v equals 6. Here comes a problem. You know, when I say problem, it could be a dead end. And the worst part about a dead end is you got to back out of it. And this might be a really tough dead end to get through, but I don't think it looks that bad. So I'm going to kind of write it down for you. And what do you get? Well, you know, I'm going to do this one first because it looks so easy. What do you get? You get u squared minus v squared is equal to 6. That's not bad to come up with that. Now let me do the other guy. Much more work, by the way. It's u squared plus 2uv plus v squared plus u squared minus 2uv plus v squared plus 2u plus 2v plus 2u, whoops, minus 2v equals 23. I got troubles. Let's talk about them. Well, this is in trouble. That disappears. This disappears. But then I'm left with a bunch of things. So what am I left off with? I'm left off with 2u squared, 2v squared, right? And then what do I get? I get 2v plus 2u. Oh, I'm sorry, I made a mistake. You know what my mistake is? My u's and v's look alike. I got to erase this. I'm sorry about that. I got dizzy there. Sorry about that. Let's go back over again. I'll be careful. So u squared plus 2uv plus v squared plus u squared minus 2uv plus v squared plus 2u plus 2v plus 2u minus 2v equals 23. Let me get my red pen out. That disappears. The v's disappear. Let's write it down now. What do you get? You're going to get 2u squared, 2v squared, and you can get 4u's equals 23. And so it's still a dead end. You still got a bunch of letters in the problem. At least they're getting smaller. And what else do you get? You get u squared minus v squared is equal to 6. So I'm at this level of the game now. I'm at that level of the game now. Now I'm looking at this thing over here, and I'm wondering what to do with that. And I'm looking at it, and let's take a look here. I'm going to multiply the second equation by 2. Let me put that down for you. And so this is why you're doing that. I don't know. It looks like I could get rid of something. So you get 2u squared. I'll be careful with my u's and v's, by the way. 2v squared plus 4u is equal to 23. And what do you get here? You would get 2u squared minus 2v squared is equal to 12. And I'm going to add these together. What do you get? 4u squared plus, the v's disappear, right? 4u is equal to 35. I'm at one letter now. And this is good news for me, by the way. And the reason that there's a good chance I can factor this problem over here. If not, though, I got to go to quadratic formula. So I'm going to put down 4u squared plus 4u minus 35 equals 0. Well, let's write this down. I'm going to give it a shot. I'm going to say 2u and 2u and 7 and 5. Whatever I write down, I'm going to check it, by the way. Let's see. 2u times 2u is 4u squared. 5 times 7 is 35. 14 minus 8. Let's see. 14. I'm sorry. 14 minus 10 is 4. I don't know why I said 8. Okay, so that's going to be plus, minus. Let me just check it. 4u squared. That works beautifully. 14 minus 10 is 4. That works beautifully. Yeah, it looks great. So I found the u now. Let's write this down. What's u? Let's see. It could be 5/2. And the other one is or. It could be something else. What else could it be? It could be u is minus 7/2. All right. So I got the u. I don't want the u though. I want to use the u to get back the v now. All right. Now why is that? If I can do this, if I know u and v, I'll know the x and y, and that's my goal. So here comes the problem, and I'm not saying it's an easy problem. What I'm saying is a problem that's worthwhile doing. All right. So what I'm going to do is I'm going to say, if u is 5/2, what am I going to use? I guess I'm going to use this. And I know this is tough. So if u is 5/2, what's u squared? It's going to be 25/4, right? Minus v squared is equal to 6. Well, let's see what I get. I get 25/4 minus 6, which is 24/4, would equal v squared. Well, v squared is 1/4, so here the v would be plus or minus, and this is a problem for me. It's a lot of different things to look for, plus or minus 1/2. All right, a lot of work. Now, I'm going to erase my chicken scratch over here. That's a lot of work. I got some u's and v's here to really worry about. And now I'm going to do this other u, which is minus 7/2. And again, I want to point out I'm plugging it in. Let me make sure you know I'm plugging it in here. Let's go for it. You get 49/4. Don't be alarmed. We're just writing these things down. Minus v squared is equal to 6. I got to do this now. So it's going to be 49/4 minus 24 quarters. That's 6, by the way, is v squared. So v squared would be what? 25 quarters, right? What's square root of 25 quarters? Let's write this down. V could be plus or minus 5 halves. All right, I got a lot of work to do on my hand now. And someone says, so much work, I don't want to go there. All right, so I'm going to put down the 5 halves plus or minus 1 half. That's this guy right over here. Let's see what we get. So what could x be? 5 halves plus 1 half. Right? 5 halves plus 1 half is 6 halves, which is 3. That was nice. And what would the y equal? And again, we're just doing this one. We'll do one at a time. 5 halves minus 1 half is 4 halves, so the y would be 2. So I'm going to just say that this could be a solution to the problem. Now, if I made a mistake, it's not a solution, but I don't know. Let's do the other one. So the other one's going to be what? X equals, now I'm going to do the half, the minus 1 half, right? So it's 5 halves minus a half, which is 4 halves, which is 2. And what's the y going to be equal to? Well, 5 halves minus a minus 1 half is 6 halves is 3. So what do I get? I have 2 solutions now I think are going to work. Before I commit to them, though, I want to try the other one now. And the other one's what? That was this one over here, right? So let's write this down. So u equals minus 7 halves. I know it's a lot of work, by the way. And the v is plus or minus 5 halves. Well, I got to do it again. All right, so let me just outline it. I think this is an answer here. I think this is an answer here. And now let's try the other one, see what I get there. I'm not going to commit to it, though, until I try. And I'm going to try to get the x again. I'll put this over here. And I'm going to say the x is u plus v. And I want to do the plus first, because I think it's easier for me. So minus 7 plus 5 is minus 2. Minus 2 divided by 2 is minus 1. What would the y be? Be minus 7 halves minus 5, which is minus 12, divided by 2 is minus 6. I think that might be an answer, too. I don't know. Let me get my little thing out. We'll have to check this later. Now let's do the other one. That's going to be the minus now, right? So it's going to be minus 7, minus 5, minus 12. So the x would be minus 12 over 2, which is minus 6. I think you're seeing something. At least I hope you are. What's the y going to be? It's minus 7, minus a minus 5, which is plus 5, minus 1. Okay. I think you see a lot of symmetry here. I was kind of expecting to see that, by the way, because it's a symmetric problem. But here's the problem. I don't know if they're right. So someone says, are you going to check those? Yeah, I'm going to check every single one. Let me check this one first. And I'm going to be honest with you. They're really easy to check here. So I'm going to say, let's see if they all check here. And they do. Every single one, the product of them is 6. Every single one. Now I got to worry about this. Let's see if this works out. What do you get? 9. I'm checking this one over here, by the way. Plus 4. Plus 6. Plus 4. Equals 23. This worked beautifully. This is a good answer. I hope you realize this one's also going to work. I just did the 3, 2, 2, 3 would work. Let's see if the minus 6, minus 1 works. And I just got to check one of them because it's symmetric. Let me erase this over here. And let me do it. And what do you get? Well, I'm going to just do this one here first. It's 36 plus 1 minus 12 minus 2. Let's see. 36 plus 1 is 37. 37 minus 12 is 25, and 25 minus 2 is in fact 23. So I got 4 solutions to it. Was it a lot of work? Yeah. Was there a trick there? Yeah. Let's see if we got the right answer though. And again, I want to look at this. I think the answers are listed for me here. Let me make sure you know what I'm looking at. Let's see, 2, 3. Let's see if I got the other one. 3, 2, minus 6, 1, minus 1, 6. Let's look at the graph. It's over here. And I'm seeing it. I'm seeing the 3, 2. I'm seeing the 2, 3. I'm seeing the minus 6, minus 1. And I'm seeing the minus 1, minus 6. I'm seeing them all. All right. I know this is difficult. I want to point out, though, if you have the ability to graph this thing, this would be a far simpler problem to start with. And the reason for that, you're going to notice that graphing these things over here, again, I'm not saying you're at this stage over here, it graphs as a circle, and this graphs as a hyperbola. And let me point out to you, I see the circle, hyperbola. You know, again, you have to graph them out. You get a rough idea where the solutions are, and then you can start to attack the problem, all right? Okay, this is also, I'll be honest with you, they're tough problems. I mean, they're really, really tough problems. And looking at it, you know, bottom line, you know, kind of looking at, I don't know where I would start with it, to be honest with you, unless I was going to look for a trick. And, you know, one of the tricks you could do, I guess, is what we did before. And I'll write that down. I'll say x equals u plus v, and y equals u minus v. If I add those two together, you get x plus y equals 2u. And I know xy is going to be minus 1. All right, I know that. How do I know that? I'm looking at the system. So what's u? Is minus 1/2. All right? Now I'm going to write that down for you. So x equals v minus 1/2. What does y equal? Well, it's going to be minus 1/2. That's what u is, right? Minus v. All right. I got that part done. All right, now what do? I got to plug them in. And that can be tough. I'm not saying it's going to be easy for you. I got to do the 4th powers. I'm going to put down x4 for you. And let's do that. It's going to be v4. Yeah, I'm going to put down Pascal's triangle for you. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Let's write it down. So next guy's going to be what? Minus 4 v cubed times 1/2. Let's put the next guy down. What's that going to be? Let's see. I got 1, 4. I got 6 now, right? 6 v squared. Right, that's not so bad. And then it's going to be 1/2 squared, which is 1/4. Then it's going to be plus 4 v, and then it's going to be, I'm sorry, not plus, I'm sorry. I got a mistake there. I'm daydreaming. Minus 1/2. And then I'm going to get plus, I'm sorry, that's 1/8. I'm cubing it. And last but not least, you can get 1/2 to the 4th power, which can be 1 over 16. All right? Now I want to look at this guy over here. I think it might be just as easy, but here's the deal. This is the same thing as squaring v plus 1/2. I'm sorry, cube to the 4th power. All right, let me write this down. So x4, I'm going to clean it up. v4 minus 4. No, I'm not going to put 4 down. I'm going to make it simpler, right? That's just 2 v cubed. This is going to be plus 2. I'm sorry, not 2. I'm really daydreaming here. Let's see, 6 divided by 4 is 3/2, right? Minus 1/2 of a v plus 1/16. I'm going to write down y4. And what do you get? v4 plus 2v cubed plus 3/2 v squared plus 1/2 v plus 1/16. That was pretty easy. And someone said, how'd you put it down so quickly? I just did the other one. This one wasn't much different. So x4 plus y4, well, that's equal to what? Oh, 97. Let's add this thing together. What do you get? 2v4. Let me get my red pen out. These disappear. These disappear. And I think I'm ready to start adding things together. Let's see. 3/2 plus 3/2 is just 3, right? 3v squared that's a tough one, isn't it? 1/16 plus 1/16 is 2/16, which is 1/8. All right. I'm looking at this guy now. Whoops, sorry about that. I'm not saying this is easy, by the way. I'm just saying you can move forward. I have an equation in one unknown now, but it's a 4th degree, and it looks tough. I got to multiply both sides by 8. Let me write that down for you. 8 times 97. Let's see, 56. And 8 times 9 is 72, 77. I'll write that down for you. 16 v4 plus 24 v squared plus 1. Boy, this looks like it's a tough one, doesn't it? 0, 16 v4 plus 24 v squared minus 775. Well, you know what? It looks sort of quadratic in form, so I'm going to try to do it. What I mean by that, I'm really going to try to factor that guy. So it's 0. And I'm going to say, looking at it, I'm just going to start. I don't know if it's right, but I'm going to say 4v squared and 4v squared. And I'm looking at that. Oh, that looks really tough to me. 4v squared, 4v squared. I got to do it. I'm looking at it, and I'm looking at the 775. I'm just going to divide by 25 because it looks like it goes in a nice number of times, right? So that goes in 30, I should say, 75 or 750, 20, 31 times. All right, you get the idea? I'm going to write that down. I'm not saying it works, by the way. I'm just saying 775 and 1's not going to work. All right, I also probably wouldn't say 155 and 5 wouldn't work. But I'm going to try something. I'm going to try 31 and 25. Again, I'm not claiming it's going to work. I'm going to try it. Let's see if we get what we want. Let's write this down. I'm going to get some signs going here. I'm going to try it. 16 v4. Bingo. What's 4 times 31? 124. V squared minus 100 v squared. What does this give me? Bingo. And then minus 25 times 31 is 775. So I just tried. I'm going to erase that now because it's just me doing some, not trusting myself. And I shouldn't trust myself anyway. I should just do what I can, which is check myself. I know it's tough. This is a V. This is 2V minus 5, 2V plus 5, times 4V squared plus 31. I want to point out something to you. This is a complex solution. I want to concentrate on the real solutions. And I got it. What's it going to be? I'll write this down for you. The V could be, let's see, 5/2, or the V could be minus 5/2. Now, by the way, part of this is just, understanding that we got something over here. And I know the U is minus 1/2. And now the V can be plus or minus 5/2. We got that right over here. I'm going to do this now. And someone says, what are you going to do? We're going to write the X and Y down now. I want to do the plus first. Minus 1/2 plus 5/2 is 4/2, and 4/2 is 2. Let's do U minus V. That's minus 1, minus 5, minus 6 over 2 is minus 3. We'll check that later. Let's do the other ones. X equals, we're doing the minus sign now, minus 1/2, minus 5/2, minus 6/2, it's minus 3. By the way, this is also a symmetrical problem. Y equals 2. Let's check it. And I don't know if they're right until I check it. I want to point out, they're really easy to check here. Is the sum of those two numbers minus 1? Absolutely. Absolutely. The next thing I want to really determine if I did the fourth powers of those numbers, would they cut the 97? What's the fourth power of 3? It's 81. I'll write that down for you. And what's the fourth power of 2? 2 times 2 is 4, 8, 16, right? What does this give me? 97. These are two good solutions over here. Let me take a look, though. I want to look at the graph, and I'm going to see if I'm getting the answers 2 minus 3. And the other one over here, I want to point out it looks like minus 3, comma 2, like they said it was going to be. Now, granted, I do concentrate on getting the complex solutions. I want to point out, for me, they're a lot of work. I'll write that down for you, though. 4v squared equals minus 31. V squared is minus 31 over 4. So V would equal plus or minus root 31i over 2. And I want to point out that, to me, it's work, all right? Now, what do you mean by work? I still have to put the U down. What was the U? Well, if you don't remember, it's up here. It's minus 1/2. And what's the X? Well, if you don't remember, I wrote it down. It's U plus V. What was the Y? If you don't remember, I wrote it down up here. It's U minus V. And we could find the other solutions of this thing over here. Now, why is that? It's really not bad to do, but it is work, though. And what I mean by that is, the X is going to be minus 1/2 plus or minus root 31 over 2i. And the Y would be minus 1/2 minus plus root 31 over 2i. Now, certainly we write all the answers down for you. I know it's tough, but it put the complex solution down if you want to look at those. But visually, what are you seeing? You're seeing 2 points of intersection. And what is this? It's a line. This is a line. And the other thing, it kind of looks like almost like a squared circle. All right, this thing over here. All right, and it's a tough section. I understand some of you are going to say, I can't do this, I can't do it. I had a tough time with it too. I'll be honest with you, I had a real tough time with this. What I mean by that, it took a lot of time and effort to get through it, all right? But what do you do over here? Exercises. What I'm going to claim over here is it looks similar, and certainly when I say it's similar, this looks similar to the problem that we just did, and I put all the work down for you, what the substitutions were, all the work. Well, it looks almost like the same picture. I write down the complex solutions, but I want to be honest with you, more important, at least I hope I did. I think I put down let's see if the nice solutions, all right? But I also put the complex solutions down over here. Nice solutions really do work out nice. These problems are carefully selected, by the way. Number 2, it does look like a familiar problem to me. It really looks very familiar, all right? We've done problems like this before. And again, you start to say to yourself, do I need to look at your work to the problem? I hope not, but if you get stuck, look at my work. What do? I put the solutions down for you. I put the graph down for you. And the solutions for this one, it's not bad. 1, 6, and minus 6, 1. Let's see if I did that right. 1, 6, and minus 6, minus 1. But I'll be honest with you, there's other ones that are really problematic for students. All right, they're tough. They really are tough. But you can get them. All right, you can get them. All right, you can get these. All right, I got them. You can get them. All right, this one over here, it's a nightmare. I'll tell you why. The parameter. It makes it much more difficult. Do I go through the work? Yeah, I go through the work. Do I get the solution problem? Yeah. What I'm not providing, though, is a graph on it. I'm not providing a graph. Again, if you're looking at your work and my work and can't get them to coincide, maybe I made a mistake. But I don't think I made a mistake. I think I did pretty good in this, where I spent a lot of time and effort on it. Again, system, I write down, what I did with the system. I actually put down the solutions to it. 2 are really nice, and they're not bad. They're okay. But I put a graph down with the 4 points of intersection for you to look at. Same for this one over here. Again, I work on it. Yes, it takes me time and effort. I get some nice little solutions over here. I get some nice points of intersection over here. Yeah, it's work, no doubt about it. This one over here, I did it. And I do it for all the problems here. Let's just keep going through it. And there's a lot of stuff for you to work on. I know it's tough. I found it difficult too, by the way. I found it really tough to get through some of these problems over here. It took me time. I do have tools that Wells didn't have. For example, some of my tools I have a graphic system that can actually graph these things out. And it really does a quite nice job of it. Like this one over here, you can really zoom in and carefully look at the curves if you like, and seeing how nice these things are, how nice they intersect. But again, I go through all the work, put the solutions down. This one over here, yeah, tricky, tricky, tricky. But the more effort you put into this, the more apparent these tricks will become to you. And they're not, I'm going to say they're not easy to get through. Some of these took me pages of work to get through, and time. I'm talking about hours of work on a particular problem. It might have taken me hours to get through it. All right, making a mistake, dead ends, starting again, dead ends, starting again, until I see it. And eventually you'll see it, all right? Why do I think I'm going to see these problems over here? Basically because I believe that you're giving me problems I can do. And that's nice. It's a good way to go through life. If you're given a problem and you can believe you can actually solve those problems, that's a nice thing. Having tools at your disposal, not bad if you have them, all right? A large number of problems here, right? 13 already. Let's keep going through it. 14, 15, 16, are they ever going to stop? 17, are they ever going to stop? 18, know this, life is finite. All right, I'm running out of power. I'll get there soon. I got to make sure I'm doing that. Yeah, let me get to the Sage business. Let me be real quick about this. Computer algebra system, it's free. Go to this website, download it, or internet application, do some code. If you need to reach out to me, my email address is Bannon, that's B as in boy, the @ symbol, NNON.US. I am particularly interested in any errors that I've made in my notes. If you found an error, please point it out. Thank you so much.